Lesson 2.10, Assessing Risk. Our objective for this lesson is to be able to find the incidence rates for different events and use them to compare the risk of the events happening. First, let's define incidence rate. Incidence rate is a measure of how often some event is likely to occur over a particular period of time. The reason that we calculate incidence rate is so that we can compare two events in a meaningful way. Let's say, for example, that we want to compare the risk of taking a shower to the risk of skydiving. It's not enough to just compare the number of people who have died by slipping and falling in the shower compared to the number of people who have died by skydiving. We need to compare those as a probability and over the same period of time. So for example, we could take the number of people who have died by falling in the shower divided by the number of times that people have taken a shower in that time period, let's say 1 year. And then we're going to compare that to the number of people who have died by skydiving divided by the number of people who have participated in that activity over the same time period. So that now we're talking about rates, we're talking about probabilities rather than just raw numbers, and that's going to be a more meaningful comparison. All right, so calculating incidence rate. An incidence rate is essentially a relative frequency probability. So we're going to calculate that the same way that we would calculate relative frequency probability. The number of total events, or the number of times an event has occurred divided by the number of possible possibilities for that event to have occurred. So, but when we're talking about incidence, these rates are often calculated per 100,000 people. So to find the incidence rate per 100,000 people, we're going to use this formula. The incidence rate is equal to the number of events times 100,000 divided by the total population. And the reason that this is done is, let's say that we've got two viruses, virus A and virus B, and the probability of a single person dying of virus A is 0.002. And the probability of someone dying of virus B is 0.008. We might have a tendency to look at those and just see two very small numbers and think of those as essentially zero and dismiss them, or think of them as essentially equal, even though virus B is 4 times as deadly as virus A. And so what we do is, instead of talking about the probability of a single person dying of this virus, we talk about the total number of deaths per 100,000 people in the population. So, for virus A and virus B, we would say that out of a population of 100,000 people, 200 of those are likely to die of virus A versus 800 are likely to die of virus B. And so it's easier to see the comparison between 200 and 800 compared to 0.002 and 0.008. All right, for our example, we are given a table of the 10 leading causes of death in the United States in 2017. And we're asked to use the information in that table along with the fact that the population of the United States in 2017 was 325 million, to calculate the death rate for Alzheimer's disease per 100,000 people. So first we're going to look on that table and see that the total number of deaths from Alzheimer's disease in 2017 was 121,404. Now, if we were calculating a relative frequency probability, we would just take this total number of deaths and divide it by the total number of people in the United States. And that would give us the relative frequency probability of any individual person dying of Alzheimer's disease. But that's not really very meaningful, because not everyone has an equal chance of dying of Alzheimer's disease. So, so it makes more sense and we're going to get numbers that are easier to work with. If we think of the death rate per 100,000 people rather than the relative frequency probability for any individual person. And so what we're going to do is we're going to take this and we're going to multiply by 100,000 divided by the total population of the US, which was 325 million. And now we have this fraction that we can reduce by canceling some zeros here. And so we get 121,404 times 1 over 3,250. And which is just equal to 121,404 divided by 3,250. That's going to be approximately equal to 37.36. So about 37.36 people for every 100,000 people in the United States, about 37.36 of them died of Alzheimer's disease in 2017. And the way that we would use this is, say, for example, we wanted to know what was the death rate for Alzheimer's disease versus heart disease, for example. Or maybe we want to know the death rate for Alzheimer's disease in the United States versus the death rate of Alzheimer's disease in Canada. Then we can compare those in a meaningful way. It wouldn't make sense to say, well, 121,000 people died of Alzheimer's disease in the United States, and only 10,000 people died of Alzheimer's disease in Canada. That wouldn't make sense to just compare those two and say, oh, look how many more people are dying in the United States of Alzheimer's disease. Because the United States has about 9 times as many people as Canada does. And so that's why we're putting this in a rate to where we can compare these things in a meaningful way. So that's all incidence rate and assessing risk.